So here's a crane, and it's gonna lift a bucket, okay? So cranes that just lift empty buckets don't sell very well. It's like, what does your crane do? Lifts an empty bucket. Can I put anything in it? Nope, just a bucket. Cool, sign me up. So within the bucket, oddly enough, there's gonna be some dirt. So one of the things we're gonna talk about eventually is density. So this is just kind of an introduction into density from a physics perspective. So up to this point in time, in your esteemed science of density, you probably saw density as mass divided by volume, and it was probably grams per cubic centimeter or grams per milliliter, because that's the chemistry version of density, right? Physics, we have a different version of this. It's still the same idea. But instead of D, we use the Greek letter rho, which is kind of like a slanted value of P. Okay, it's the Greek letter rho. It's still mass divided by volume, but the mass, because we're in the MKS system, is in kilograms, and the volume is in cubic meters. So in chemistry, it's mass per cubic centimeter, which is about like yay, which is about the volume of the end of your pinky. In physics, it's mass per cubic meter, okay? Same idea, vastly different units. So what's happening on number 8, I've given you the weight of the bucket, okay? So you gotta lift the bucket, it's kind of part of the deal. So I've given you the density of the soil, 2.00 times 10 to the third kilograms per cubic meter. I've also given you the volume of the soil, 1.15 cubic meters. So you need to take the density times volume to get the mass of the soil. But you need the weight of the soil. So how are you going to find the weight of the soil? Multiply by 9.8 meters per second squared. And then what are you going to do with the weight of the soil? Add that to the weight of the bucket. And then you have your height. When you get down to number 11, pay attention to the demo that we did in the back. You have two different objects, a smaller object and a more massive object. A has a larger mass than B. And it says, which object will travel further, explain. And in big bold letters and underlined, I said, as part of each answer, you need to include an equation. And you just can't say, oh, A is going to travel farther because it has a bigger acceleration or a smaller acceleration, or because it's the letter A and A is faster than B. It's not it. You need to say, like, why. Oh, it has a bigger acceleration, but distance equals something, 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 okay? So in other words, you just cannot base that off of an acceleration. You need to say how that acceleration translates into a distance, okay? All right, I'm done. You have work to do.